and welcome to GCSE Chemistry, topic C3 Quantitative Chemistry. This tutorial will look at calculations in chemistry, as well as the higher section and atom economy. First of all, you will need to know how to balance equations. So these questions can come out throughout the whole of the exam. When you're balancing an equation, you need to make sure the number of atoms on each side of the reactant and product side are the same. Now, you can't go and change the formula of an element or compound, but you can put a number in front of them, and that then multiplies the number of atoms in that element or compound by that number. Let's look at an example. This is a reaction between nitrogen and hydrogen to make ammonia. At the moment, it's not correct because it's not balanced. And what I mean by that is there's two nitrogen atoms here and only one nitrogen there. There's two hydrogens here and there's three hydrogens here. So how would you balance it? If you put the number 3 in front of hydrogen and the number 2 in front of ammonia, you've now got 3 times 2, you've now got 6 hydrogens, and then 2 times 3, you've got 6 hydrogens here. You've got 2 nitrogens here, 2 nitrogens here. Remember, the number in front multiplies the number of atoms. So this is now balanced. You need to know how to calculate the relative formula mass. For example, what is the relative formula mass of copper oxide? Well, to do this, you need to look up the mass number in the periodic table. Now, you're not going to find copper oxide in the periodic table, but you will find the elements it's made of, so copper and oxygen. Copper has a mass number of 63.5 and oxygen has a mass number of 16. So you just add those together because there's one atom of copper and one atom of oxygen in copper oxide, and that makes 79.5. You also need to use relative formula mass to look at the percentage mass of an element in a compound. So basically, how much of an element is there in a compound? This question is an example. Find the percentage mass of carbon in carbon dioxide. So first of all, find out the relative formula mass of carbon dioxide like we did before. In the periodic table, carbon is 12 for the mass number and oxygen is 16. Now there's 1 carbon and 2 oxygens, so you do 16 times 2 plus one of the carbons, which is 12, which makes 44. So carbon dioxide has the relative formula mass of 44. The question is, how much of the carbon dioxide is carbon? Well, carbon is C, and there's only 1 carbon, so it's just 12. 12 divided by 44 times by 100 gives 27%. You also need to know about this term, the mole. The mole is the amount of a substance. 1 mole of a substance is the amount that substance contains an Avogadro number of particles. And that Avogadro number is 6.02 times 10 to the 23 particles. Now, you need to be able to say how much 1 mole of different elements weighs. And all you need to do for that is look at the mass number. So 1 mole of carbon weighs 12 grams. Where did I get 12 from? Well, 12 is the mass number of carbon from the periodic table. You can also use this to find out the number of moles in a certain element or compound. So the question is, how many moles are there in 66 grams of carbon dioxide? First of all, find out the relative formula mass of carbon dioxide, which is 44. Then take the mass, which was 66, divide it by 44, and that gives you 1.5 moles. In any reaction, there is always the same number of atoms on each side of the reaction, so in the reactant and product side. And that's because when things can react together, you don't gain mass or lose mass, instead it's conserved. So we call it conservation of mass. If you look at these examples here, the question would be asking you, how much mass did you start with? And it's quite simple, you just add together the mass of the products. In actual reactions, the mass can actually appear to go down or up, and that might be because you made a gas and therefore the mass of the product will go down slightly because the gas will escape, or you might have an increase in mass because you didn't weigh accurately one of the reactants in the first place, which would have been a gas. The empirical formula, that's the simplest formula a compound has, and you can determine that using the ions from the ionic compound. So what's the empirical formula of calcium chloride? Well, we know calcium atomic number is here, so its atomic number is 20, so it's 2882. So it loses 2 electrons and it becomes C2+, Ca2+, sorry. Chlorine gains 1 electron to become Cl-. So these are the ions that they form. But how do they join together? Well, because they're not balanced, there's a 2+ here and a minus, you need 2 chloride ions to balance out the calcium ion. So in fact, the formula would be CaCl2, which means 2 chlorines for every 1 calcium. Reactant masses. If you know the masses of reactants and products, you can figure out the balance symbol equation. What you have to do is divide the mass of each substance by the relative formula mass to find the number of moles. Then divide the number of moles by the smallest number of moles in the reaction. If the numbers are decimals, then you can multiply them up to get whole numbers, and then you can write out the balanced equation. Let's look at an example. It says 84 grams of nitrogen reacts with 18 grams of hydrogen to make 102 grams of ammonia. So how would you write that out as a balanced symbol equation? First of all, find the number of moles for each. So write out the elements and compounds, so nitrogen, hydrogen, ammonia, and then take their mass and divide it by the relative atomic mass. So nitrogen is 14 in the periodic table, but there's 2 of them, so it's 28. Hydrogen is 1, but there's 2 of them, so it's 2. Ammonia, you need to add together 14 plus 3, which is 17. That then gives you the number of moles. The smallest number of moles is 3, so divide each one by 3, and that gives you 1, 3 and 2, which means there's 1 nitrogen, 3 hydrogens and 2 ammonia, which you then put into the equation so that it's balanced. Reactions don't actually go on and on. Eventually they will stop. And if a reactant gets used up before the other reactants, it is limiting. The amount of product you make is directly proportional to that limiting reactant. To find the mass of a product, you'd write out a balanced equation, you'd find out the relative formula mass of the reactants and products, find the number of moles, and then use a balanced equation to work out how many moles of the product there will be. And then you can figure out the mass of the product. You also need to know how to calculate concentration. Concentration is measured in GDM3. This means whenever you've got a concentration in centimetres, you need to divide it by 1,000 to convert it into dm. Here's an example question. What is the concentration of solution of sodium chloride where 20 grams of sodium chloride is dissolved in 500 centimetres of water? Before you do anything, convert the 500 into 0.5 dm by dividing it by 1,000. Then you would just do the mass, which is 20, divided by that volume, which gives you the concentration. These are higher calculations that would be in the higher exam paper. You would also need to be able to calculate the volume of gas. And you would need to know that 1 mole of any gas occupies 24 dm at 20 degrees. So the question is, what's the volume of 200 grams of chlorine at room temperature? Well, you take the mass, divide it by the relative formula mass of chlorine, which is 71, and then times it by this number 24. You also need to know you can calculate concentration in another way as well. You can calculate it in moles per dm by doing the number of moles divided by the volume. An example is shown here. You also need to know about how concentration can be calculated in titration practicals. Titration comes up in the acids topic later, but here's an example of a question. It said a titration showed it took 30 centimetres of 0.200 mole sodium hydroxide to neutralise sulfuric acid. The student started with 40 centimetres of sulfuric acid. What's the concentration of the acid? First of all, find the number of moles of the known substance. The known substance in this example is sodium hydroxide. So the number of moles would be 0.200, so the concentration, times by the volume. Remember, you need to take that 30 and divide it by 1,000 to get it in dm. So that gives you the moles of sodium hydroxide. Then you look at the equation. In the equation, you can see that there's 2 moles, the number 2 here, of sodium hydroxide for every 1 sulfuric acid. So that means you need to divide it by 2 to get how many moles of sulfuric acid there are. So there's 0.003 moles of sulfuric acid. And then you would find the concentration of the sulfuric acid. So you take that number and you divide it by the volume. Now remember, the volume was 40, but we need to change that to 0.004, and that gives you the final concentration at the end. It's worth pointing out these questions would be worth 3 to 4 marks because they're of a more difficult nature. Finally, atom economy. That is the percentage of reactants forming useful products. To find the atom economy, you would take the formula mass of the desired product divided by the formula mass of all the reactants and times it by 100. It is useful to have a high atom economy because it means there's less waste and there's more yield and profit. But you need to make sure that the waste that you do make can be used as byproducts. What is the atom economy of this reaction here? Well, first of all, find out the formula mass of NH3, the product, which is 34. So it's 17, so 14 plus 3 times by 2, 34. Then the atomic mass of nitrogen and hydrogen, which is also 34. And then you would take the desired product, which is ammonia, and divide it by all of the reactants, which were also 34. So in this case, it's 100%, but it's not always going to be 100%. The percentage yield, that's how much you make. It's the mass of the product divided by the mass of the theoretical yield times by 100. Theoretical yield is how much you should make, actual is what you actually do end up making. Often, you don't get 100% yield because not all the reactants react together, like reversible reactions. Sometimes the reactants and products are lost. Sometimes they're side reactions. So as a compromise, you often have to compromise the situation of your reaction to get a low yield, but overall making a profit. In summary, we've looked at calculations in chemistry, in higher chemistry, and atom economy.